Okay, welcome back to the beginner-friendly Spring track. I hope you enjoyed the break. Next up, we have a talk titled Connecting Spring Apps to Distributed SQL Clusters Running in Kubernetes, brought to us by Tony Vetter and my friend and former colleague, Nikhil Chandrappa. So good luck and take it away, guys.
Thanks you all for joining. My name is Nikhil Chandrappa. I'm a lead software engineer at YugabyteDB. I work in the drivers and ecosystem team. This is actually my fifth Spring 1 conference that I'm attending, second time speaking at the conference. Super excited to be talking to you folks. Also, I have along with me Tony Vetter. He's a senior product marketing manager at VMware. We are here today to talk to you guys about cloud native Spring microservices and distributed SQL backend on Kubernetes. Just a disclaimer about a few forward-looking statements that we're going to make. I just wanted to do like a standard disclaimers. I wanted to put it out there to make my legal team happy. Before much ado, let's get started, right? Obviously, as we move towards the cloud-native era, right, like application developers and architects who are trying to build high-performant APIs, one of the things they want to they want to think about is how they architect their data access patterns and the database itself, right? They have like plethora of options. They have like whether they have to go with a NoSQL database or a SQL database, and how do they scale their workloads, and what is the SLA requirements that they need for the APIs. On top of that, they have to like also think about how to move their applications between private and public cloud, how to deploy in multi-cloud. You see, right, there's like a lot of decisions an application developer has to make. And also designing the database for all these cloud and different workloads becomes challenging. That's why we see databases on the cloud is a hard problem to solve. If you see some of these pictures out here, right, these are like outages that happened in some of the top e-commerce, like some of the top internet companies out there, like HBOs of the world, the GitHub, Targets, right? So if you see one of the situations in GitHub, what they had is they had a network outage, and what happened is the databases between West and the East data centers lost replication. Like all the writes they were doing on the West data center, they were not flowing onto their onto their East data center, which actually resulted in inconsistencies between their databases, which actually resulted in their application going down. As you can see, like apart from having infrastructure outages, there's like a bunch of other limitations that we see in the database, like the traditional database itself, when we move to the cloud native era, in how you can scale and how you can make your database resilient, right? So some of the things microservices architecture faces, like as and when number of microservices kind of increases, so there is a connection exhaustion that might happen on your relational database itself, or traditional SQL database. And also it results in a higher latency. And extreme cases, in order to avoid your database itself going down, what people usually do is they kind of resort to query limiting. Like one of the advantages of moving to the cloud obviously is like to have scalability, right? Scalability and kind of unexpected like traffic patterns. Whenever you get things like that, you can easily scale. But query limiting kind of it's like a disadvantage in your cloud native architecture itself. So in order to solve some of these things, there's like a bunch of ways that a developer can scale their databases using read replicas or using NoSQL way of accessing data. But today, in this presentation, we are going to talk about distributed SQL, a new way of scaling out your relational workloads. What distributed SQL means is distributed SQL database architecture provides like massive scalability by sharding your relational workloads, and also it provides high resiliency by having multiple copies of that same data in your cluster, so that you'll have 24/7 or like high SLA requirements that you need in your cloud databases. You are able to support that. On top of that, they are trying to bring in, or what they provide out of the box is providing distributed transactions, and also support globally distributed database topology, which means you can have your databases sit in East, West, Central, or Asia, Europe, and US, and have all your data in sync. So these are like some of distributed SQL concepts which are becoming popular these days with application developers. So Amazon Aurora and Google Spanner are some of the popular distributed SQLs out there in the public cloud. So Amazon Aurora, if you don't know already, it is one of the most popular AWS services out there, and it is like the fastest growing apparently in AWS. What Amazon Aurora provides is Amazon Aurora provides a highly available MySQL and Postgres compliant relational database, and it kind of uses the traditional way of scaling out databases using read replicas. Whereas in Google, what they did is they went ahead and created their own distributed SQL, or like a linearly scalable database, which is their first horizontally scalable, strongly consistent relational database in Google Spanner, which you can use in Google Cloud as Cloud Spanner, right? So it provides scalability, HA, everything out of the box. But one thing what they had to do is they couldn't support the entire RDBMS features. The things like foreign key relations, say foreign key constraint doesn't actually work in Google Spanner yet. However, Amazon Aurora doesn't have those limitations. It can kind of support all the RDBMS features, right? So obviously you see there's like few advantages and disadvantages to each of these database architectures. In today's talk, we are specifically going to concentrate on Google Spanner type databases, which rely on time-based consensus algorithm for doing distributed transactions. If you see Google Spanner itself, Google Spanner uses something called as Paxos. Paxos is based time-based consensus algorithm, which uses atomic clocks for coordinating transactions. And obviously, atomic clocks, right? Like not a lot of us will have atomic clocks lying around in our data centers. If you want to run your workloads outside of Google Cloud or in your data center, what you're going to do with Paxos, right? So there's another class of distributed SQL algorithms, databases, which actually make use of something called as Raft consensus algorithm. It is basically based on a logical clock, not atomic clock. What happens is when you use logical clocks, you kind of have a clock component that goes along with your RPC calls. Like whenever you make a write RPC call, there will be like a clock that gets associated with it, depending upon which you can determine which write wins. So in Raft consensus, each shard will have leader and followers who form a Raft consensus ring and provide high throughput and highly consistent reads and writes for your distributed or relational workloads. This is how they are able to shard your data set itself so that they can do linearly scale. But how do they provide the relational database capabilities itself, right? Like the entire capabilities. So the way they are able to do that is by reusing the entire upper half of the query layer. So for YugabyteDB, which we are going to use today for connecting to a Spring microservice, actually reuses the Postgres query layer itself so that it can support all the RDBMS features. However, on the replication and the storage layer itself, it deviates from Postgres and uses a storage layer which implements a Raft consensus algorithm, so that you get all the data sharding and global replication, distributed transaction out of the box. However, for a Spring microservice itself, it's like all the nodes are identical. You can have your Spring microservice connect to any node and make Postgres queries. You'll get the results. As an app developer, you don't have to make any changes in your code. Your existing code will continue to work with few application property changes, like pointing it to the load balancer, which connects to this, or using a different data source, which Tony is going to talk about next. Now, going into Spring framework support for distributed SQL itself. So we all know Spring Data is one of the widely used Spring projects out there. Like pretty much everybody, whoever is a Spring user, probably use one of the Spring Data projects out there. It kind of provides a really good abstraction for accessing data using repositories, right? Like you have a common set of APIs which you'll use for connecting to any database. Spring Data JPA and Hibernate obviously is like super popular for connecting to relational workloads, and underneath it uses JDBC drivers for doing so. When it comes to the distributed SQL databases, obviously it is not single node database, right? You'll have multiple data nodes where your JDBC driver needs to connect. In current world, if you have to reuse the existing Postgres drivers or existing JDBC driver, what you'll have to do is you'll probably have to have a load balancer in front of all your data nodes, so that you will evenly spread your data set around queries around all your available nodes. In order to avoid that, in order to bring in some of the intelligence to the driver itself, so that it can know the topology of the cluster, it becomes cluster aware. We are working towards a new JDBC driver, which is called as a cluster aware JDBC driver, which understands the cluster topology whenever there's a topology change, like new node joining the cluster, or whenever there is a node that goes down due to some infrastructure outage, your cluster-aware JDBC data source will be automatically notified that the change has happened. It's like similar to one of the approaches or one of the demos that we're going to do today is like a scaling up of a distributed SQL cluster, and how Spring microservice is going to automatically know like a new node coming in. That's all I had as part of the deck itself. It's just that we want to show how easy is it for a Spring developer to get started with distributed SQL with all the APIs he's already familiar with. So Tony is going to walk us through a sample Spring microservice connecting to a distributed SQL database. Over to you, Tony.
Awesome. Thank you, Nikhil. That was a great presentation. Good learning about kind of the distributed SQL marketplace and when we would want to consider moving from a sort of a singular SQL database to a distributed one. So here, like Nikhil said, I'm going to show you in a Spring Boot app. So we have kind of a simple Spring Boot app here. Basically, it's just mimics a small customer database. It's just it's an API that writes things to a database, right? And we're using customers as sort of a proxy for that. Pretty simple stuff, but we're going to be using the Spring Boot application to kind of show how easy it is to connect a Spring Boot application over to a distributed SQL cluster. Now, a little bit about this environment. It is using YugabyteDB on the back end. A lot of the commands and specific lines that I have in here are going to be specific to YugabyteDB, but the concepts are sound here for any sort of implementation of a distributed SQL cluster. Also, this is running on PKS. Again, that doesn't matter. It just happens to be the Kubernetes I'm running on because I work at VMware. Sorry, TKG. It's not a very long time. Again, this is about any Kubernetes cluster, not necessarily has to be running on this one. So the first thing I want to show you here is that we've got our distributed SQL cluster up and running. Excuse me, with 3 master servers and 3 T servers. And T servers are just Yugabyte parlance for like where the data is stored. So don't have to worry too much about that. So the first thing I want to do is basically show you our POM file. So start.spring.io is, of course, a great place where we go to add our dependencies to our Spring Boot apps, and usually it adds all that pretty automatically. For this one, we are adding one manually, and that's this guy here, this YSQL driver. Excuse me. And this is going to allow us to take our application, which is currently speaking to Postgres, a singular Postgres database, is going to allow it to speak that same dialect to a distributed SQL cluster. So we don't have any actual, like Nikhil said, we don't have any application level changes to our code. We're going to keep speaking the same dialect through Postgres, but we're going to be translating that into a distributed SQL cluster. This isn't available yet in start.spring.io. I think that the Yugabyte team is working on that, but for right now, we're just sort of adding it manually. Next, I want to show you the application properties file. Now, here what we're doing is basically we're telling Spring that we want to keep talking our Postgres dialect within Hibernate to be able to continue with our application that was normally speaking to Postgres to continue to be able to speak to Postgres, just without having to know about kind of how that data is being distributed on the back end. This is an auto update flag that we're just setting so that if there's any updates to the schema on the back end, that the application is aware of that automatically. And then we're telling our application where our data source is. So where is Postgres located? And in this case, we're using our Kubernetes DNS name for our Yugabyte cluster. And we'll use this address again in just a second. And that's really all the config that is needed to sort of tell our application how to connect. So you see that's pretty simple. And then the rest of it is just instantiating resources within our application and connecting our data to those resources. So here we're going to instantiate what Nikhil called our cluster aware data source here with our YugabyteDB cluster. And we're going to use that same address that we called out earlier. Remember from our application properties file right up here that we're using that same address here to instantiate our data source. Next, this is just our customer class. Again, this is just so we can put some data in our database. We're instantiating a table here called customer, and then we're have all of our normal getters and setters that you would normally find in our very simple Java application. And then we're going to instantiate our customer repository, and this is going to extend our JPA repository to instantiate a customer repository so that we can do CRUD operations and find our customers by different kinds of strings. And we'll walk through that in just a second. Just one more here. So this instantiates our API. I think I pretty much literally just showed you our entire application, so you can get an idea of, again, how simple this is. But this just instantiates our API so that we can call our customers and get our customers by ID, by email, and also save our customers as part of the application. Again, if you want any of this, if you want to know how to install YugabyteDB or any sort of distributed SQL cluster, if you want this application code to play with, it's all open on GitHub. Just come and join the Q&A session, and I'll be happy to share it along with the entire script for installing the environment there if you're interested. Okay, so let's go ahead and play with this application a little bit. So we'll go ahead and start this up on Kubernetes. So we're just doing a kubectl run with some limits in place for resources. Make sure that started. Let's really make sure that started. Okay, cool. And we'll go ahead and expose that service so that we can get access to it. And then we're going to wait for our external IP. This takes just a second, so it's a little bit like watching, it's like watching services deploy in Kubernetes, which is super exciting, and the thing you come to Spring One for. If you have any questions while this is deploying, please let us know in the session chat, or come join the Q&A session once we're done. And hopefully this just deploys here in just a second. Again, this is going to allow us access into our application that we just deployed. So there we go. Looking around my microphone here. Okay, so now that's exposed. We have our environment variable set here. And now we can go ahead and just save some data into our cluster. Let me do a check on time. Okay, we're still good. So we're saving Alice here as our customer ID, customer1, and email alice@wonderland.com. And we can go ahead and retrieve that from our distributed SQL database. Again, we're not doing any code level changes. These are still just the APIs that we would have implemented if this were a singular Postgres environment, but now it's being deployed across 3 different nodes on the back end, 3 different MySQL nodes on the back end. And we'll just retrieve it one more time using the email ID, and there we go. So that's it. That's really all I had. The only other thing I wanted to show, and what Nikhil alluded to earlier, was sort of these different distributed SQL offerings, whether that be from Yugabyte or Google or Amazon or whomever. We're not here to pitch anyone. Is how easy they've made it to sort of scale and implement these databases, so that they sort of take the onus off of the developer and put that onto their own offerings. So here I'm just going to scale our cluster here. Let's say we have more than one customer record, hundreds or thousands, and we need to scale from 3 nodes to 4. So that's really just, it's a Kubernetes command. By the way, K is an alias for kubectl, for those who don't know. So there we go. We now have our 4th node running. So pretty simple there to work with. Pretty simple to migrate from a standard Postgres MySQL to a distributed MySQL in this case. And thank you for joining. And if you have any questions, please come to the Q&A session. And with that, I'll hand it back over to Nikhil.
Perfect. Let me quickly get to my last thing. Okay, what we actually just did. Cool. Okay, that's what we saw just now. It's like we had a cluster-aware driver that Tony showed us. In terms of what we saw on the screen, right? Like with just a few changes, you can make your cluster directly work against a distributed SQL cluster, and you can start thinking about how you can solve problems like deploying on a multi-cloud way of deployment, whether it's whether your database, if you want to scale from your data center to the public cloud, or you have multiple copies in your data center and one copy in your cloud, so that you can spill over whenever you have heavy workload onto your cloud. So these are some of the things that with distributed SQL you are able to achieve in your modern cloud native application. So with that, I think we had that's all we had as part of this presentation. We wanted to ask you, like, if you have any questions, you can go ahead and come to our Slack discussions. Join if you're interested in knowing more about distributed SQL. Please come and join our Slack after the session as well. We're going to give you about all the GitHub projects that Tony showed about. Cool. I'll just stop sharing.
What a fantastic talk. Thank you, Tony and Nikhil. Thanks, great demo too. And as Nikhil reminded you, there's an ongoing discussion on the Slack channel associated with this talk. Also on the beginner-friendly Spring channel, you'll see a link to a Zoom for Q&A with Nikhil and Tony. And other than that, take a break, and we'll see you back here in 5 minutes for our next talk.